Okay, this is the 10-minute video presentation on for RP2 for the focus areas. So we're starting off talking and all the artifacts and explanations are of course going to be up. I'm just going to be mainly talking about presenting this quickly and evaluating the practice and the impact on student learning. So so we'll start off with our artifacts for. So the artifacts we have here come from the school I was at, are Math Pathways, which was a system they used to differentiate the maths curriculum. So each student would be working on a different test simultaneously that was diagnostically assessed for them. Now, I don't overly like this way of teaching because most of the time you're walking around with your fist or work on your modules, and unless you're doing enriched learning that time, then it becomes really boring for them, and the students don't like it, and so I'm not overly fond of it, but it stops those situations where you might be 2 or 3 topics ahead, and but the students can be way left behind, and it's those students that are left behind that need your help the most that aren't getting it in that way. Then the trick is to get differentiation occurring so that or the trick is to never leave those students behind. The trick is to keep those that race ahead. Well, obviously that's the point. Okay. So the second thing that we talk about here, some Fermi questions are type of mathematical inquiry-based learning where you've got a question such as, what is the weight of garbage thrown away by each family every year? And then, so you need to ask a series of other questions, and then you might be able to Google a few of those things. So something easier would be, how old are you if you're 1,000,000 seconds old? That's something, it's not that easy. It's still going to be a lesson. You still need to divide by, find out the number of seconds in such and such and such and such and ask a series of smaller questions. And then, but it's not the degree of nebulosity that there is with a more advanced question. So in that way, we were able to, I was able to differentiate them in terms of more advanced to less advanced groups, while still retaining the essence of this sort of enriched learning. So, yeah. So the second example we have are literacy and numeracy strategies. The literacy strategy here, I've taken this from a Year 12 chemistry lesson plan. If you notice the key vocabulary there, coagulation, flocculation, then set that out so that they are defined and researched by groups and then taken to the rest of the group. So that's better than just sort of looking it up in the textbook or having to actually teach it in sort of a less interactive way. So so the numeracy example I have is treating chemical equations like they're formulas, which they are formulas, chemical equations as if they were numbers. So they're letters, but they're numbers. So if we look at that, these sets of equations here, what they mean, we're looking for patterns in here and taking them apart and then generalizing on things that we can teach. So metal oxides, okay, we've got a metal oxide. And what do I do? Okay, I know it forms salt and water, acid and base, salt and water. All right, metal hydroxides. Okay, so that's sort of, I took it apart and paired it back to something generalizable that I could teach. So, yeah, thanks. All right, so the next one, I'm going to be talking about planning, structuring, and sequencing of learning programs. Now, this is an example of teaching stage Year 11 chemistry from 2015. This is how I did a unit plan then, and so I've just sort of talked about general topics and alkynes and alkenes and so on. What happened here is that everything was compressed. It was very heavy at this end, and so people were drawing H's on C's, and it was all very nice and lovely there. And by this end, they were like, "What's going on?" It was so compressed at the end that what I'd sort of learnt to do. So a learning for this time around is that I was much more prescriptive in what I included. So there's that sort of what I was referring to, flocculation and such. I was much more detailed with what I put into a unit plan, and sort of, so then the lesson plans were more accurate as well. And so I think the impact for student learning is that things were much more evenly distributed, and when things needed to, there was also time where things needed to have time taken over them. So we're now doing consistent and comparable judgments. Just an assessment piece that was an organic chemistry test I wrote. It was part of that unit in 2015, and I got to mark this. So I obviously had to make consistent and comparable judgments with that. I didn't actually get involved in the marking this time around, but sort of I've got three different bits of evidence here. So Cameron took time to discuss, this was the placement report, Cameron took time to discuss the performance standards with his mentor to establish a feel for the grade bands and build an idea of what will exemplify an A, etc. And that was, can you pause for a moment? Right, so this is a rubric where sort of I went through with my mentor sort of something where you might critically explores and understands that's a less this is a rubric for so these are the practical ones up this end. Obtains, records and displays findings, obtains, records and represents data, etc. And appropriate conventions, etc., highly elaborately. And so that's referring to that. The rubric, which is for this, was somewhere else. It's something I went over with the mentor. So that was a bit confused. I'll rectify this when I come to upload it. Thanks. Next one was on a professional learning session. I participated in a professional learning session, which the evidence for is there. That was on sort of moderation and task design. That was on the maths modules and enriched learning, which is something I needed to learn about, and I very much needed to learn about that prior to. Although it wasn't self-identified, it did cover enriched learning areas, and I did make a lot of learnings in those areas. Also, now 6.1. Also, the placement assessment report, the first statement here. At the start of this practicum, Cameron had difficulty executing lessons despite detailed lesson plans. Took on board suggestions about pedagogy, the level he should pitch the work, and providing sufficient background information before delving into a topic. I found that I had, after 15 years of having not practiced chemistry, such as it is in the Year 11 and 12 curriculum, I was sometimes too far beyond it, and sometimes I didn't know enough, and I found I had serious areas that I needed to relearn a lot of that chemistry, and I didn't expect that. I don't know why I didn't expect it. I thought I could just waltz in and know everything. This was the part that I assumed was fine. I assumed I needed to learn the teaching part of it, obviously, but that I could assume knowledge of the science. So yeah. All right. Now the last one. I'm afraid time has very much gotten the better of me despite timing. Now this was about professional responsibilities. What I have here are personal reflections. The first is that a student wished to email me something interesting to do with maths, and I was about to give my university address, but obviously thought about it a little bit harder. And I don't know, it's just hit me, oh, hang on, I can't do that. So I gave them my mentor's address, and they all have each other's student university addresses. So the teachers have the students, and so on. So it was fine. I had it forwarded to me, and I just said, "Oh no, I can get in trouble for that." The other reflection was, I remember at the placement back in 2015, I asked a student, "So what did you get up to on the weekend?" And he started telling me what he got up to on the weekend, and I thought, "Hang on, this is getting inappropriate." I was just asking, "Did you play sport?" So I learnt my lesson there. That's I know not to treat children like small adults, or you know what I mean. So I learned a lesson there. So yeah, thanks for listening, and yeah, thank you very much.